Look around you for a moment. Plastic bottles, clothes, food, medicines, fuel. At first glance, they seem completely unrelated, but they all share the same foundation: carbon. Let's go a little deeper. Organic chemistry is the study of carbon based compounds. Carbon is special because it can bond with itself and with many other elements, forming millions of different structures. The simplest organic compounds are hydrocarbons, molecules made only of carbon and hydrogen. These form the backbone of fuels like petrol, natural gas, and diesel. But wait, here's the twist. Hydrocarbons are just the starting point. What really gives organic molecules their behavior are functional groups. Functional groups are specific arrangements of atoms attached to a carbon chain. Add one small group, and the entire molecule changes its personality. An OH group can turn a compound into an alcohol. A CoOH group creates acids. A NH2 group forms amines. Same carbon skeleton, completely different properties. Here's something even more interesting. To manage millions of organic compounds, chemists use a naming system called nomenclature. It's not random. Each name tells you the structure, length of the carbon chain, and the functional group present. Once you learn the pattern, the names stop looking scary. They start giving you information. Let's connect this to real life. Fuels burn because of hydrocarbons. Medicines work because of functional groups. Plastics, perfumes, dyes, and food additives all come from organic chemistry. Before we wrap up, zoom out for a moment. Organic chemistry isn't about memorizing reactions. It's about understanding how carbon builds complexity, from simple chains to life itself. And that leads to the next question. If carbon can form simple and complex chains, how do different types of hydrocarbons behave differently during reactions? That's exactly where we go next.